All right, I started the recording. So, and let me know if like my internet breaks because it kind of sometimes happens. So, um, okay. So, the first question is the proof with math by mathematical induction. So, first step would be to prove true for n equals one, right? Prove true for n equals one, and also my handwriting can sometimes get pretty messy, so let me know if something's like not looking good. So okay, let's do our left-hand side first. So left-hand side would be just the derivative of e cos x, right? And then so you'd use product rule to do this, and so it should come out as ex cos x. Let's do this. Minus sine x, right? And then the right-hand side, we'll just sub it into our formula in here. So we should get um two, whoops, two to half times one, right? Because we're just subbing in one there. So, and then e cos x plus pi and 4. And then we know that there's the trig identity, the angle rule. So we can write to the power of a half as root two, right? And then we get e to the cos um x cos pi and 4 minus, let's put the brackets there, sine x sine pi and 4. Okay, and then this should, so we know that these two here cos, oops, the cos pi and 4 becomes 1 over root 2. Same with here, this becomes 1 over root 2. We need more space. So after it becomes 1 over root 2, we can just say, okay, root 2 either x 1 on root 2 cos x minus 1 on root 2 sine x. And then so we've just proved true for n equals 1, right? So we could say therefore the result holds for n equals 1. Okay, left side equals right hand side. All right, okay, and then obviously second step is assume n equals k. For what's for k is, oh, should be more than 1. For k is more than 1. Whoops, I forgot to write that in there. For k is more than 1. And also an integer. So therefore our assumption is written as d dx of k e to the x cos x equals half e k, sorry, half to the half k e to the x x plus k upon 4 okay, it's big enough. Okay. Um okay, do I keep freezing? Am I just like, is it kind of bad or it's okay? It's okay for now. All right. Just please someone scream out if yes, I did forget the cause. Um if I do freeze, because it's kind of awkward. Okay. Now that we've got our assumption, we're going to prove true for n equals k plus 1, right? For n equals k plus 1. Okay. So, all right, so we're gonna do this step. So d of dx k plus 1. Um, so we're gonna get of e to the x cos x, and then that will equal 2 1/2 k plus 1. Expand the okay, I froze again. No, this is all good. I don't know why it's freezing now. This should be okay before. Okay, I think. Okay. Um, all right, let's just continue. We won't worry about freezing or what. So we'll get the d of dx out, and then so it becomes d of dxk. Because we can rewrite this as just like um d of dxk times d of dx, right? So we've just got the d of dx out. And then we can just do e to the x cos x, right? Equals 2 to the half um k, and then oh, sorry, we're doing the left hand side. So let's just do the left hand side by itself. And then we know that this part here, right, that equals our assumption. So we're gonna basically slot that in. So our left hand side would equal d of dx 2 1/2 k e to the x cos x plus k 1/4, k is greater than 1. Okay, and then so let's just complete the derivative here. So therefore the left hand side would equal 2 1/2 k, because that's a constant. And then we get e to the x cos x plus k pound 4 minus e to the x sine x plus k pound 4. Okay, so that's our left hand side, and then our right hand side becomes oh yeah, 2 half k plus half e to the x root 2, right? The 2 and the half to the power of a half becomes root 2. And then so e to the x. And then so this is actually just one big integral, so we can expand it as that. So it would be cos x plus k pound 4 cos pound 4, and then minus sine x plus k pound 4 sine pound 4. And like again, like before, this is these are 1/2s, right? So we can just expand 2 to the x 1/2 root 2 cos x plus k pi on 4 minus 1 on root 2 sine x plus k pi on 4. And then so these cancel out, and then you just get what you have on the left-hand side, right? So 2ek e to the x cos x k pi on 4 minus e to the x sine x plus k pi on 4. Okay, and then so left-hand side equals right-hand side, right? So, and then we've got to write our statement. So, if the result holds for n equals k, then it also holds for n equals k plus 1, n equals 1, then it holds for all n is greater than 1. Okay, and then therefore proven by induction, right? Know what to do for this one. Oh, because you guys have never seen it. So what you first want to do is that this is a flow network basically, and there are sort of 3 points you can see that where everything's going towards. So we're going to call this point A, point B, and point C, right? And so for the flow in A, so this is like, we could write it as like, you know, inflow equals outflow. So, so basically at point A, what's our equation going to be? Well, we got x1 and x2 coming out of the system, right? Yeah, so x1 and x2 coming out. So it should be, oh, actually, let's reallocate this. Let's do ABC. The solution. ABC. So this should be, so at point A here, we've got the 100 going in to that point. We've also got x1 going to that point, but the outflow is x3. At point B, we've got 50, which is the inflow, and then x1 plus x2, right? And for C, we have got x3 or x2 plus x3 equals 150 because the 150 is going out. So we've got 3 variables, 3 equations. We can do we can make this a linear system. So in an augmented matrix, it can be represented as 1, 0, and 0 minus 1, negative 1, negative 1. Oh, sorry. It should be negative 100, negative 50, and then 0, 1, 1, 50, right? So yeah, so this gives us our linear system. And then B, we want to reduce it to an augmented matrix. Shouldn't those be positive ones? No. Negative x1 minus x2 equals -50. This should be, and then this should be the same. Plus x3 equals 50. All right, cool. So let's just reduce it. So the first step could be going from, let's just make, we want to in a augmented form, right? So we want to do it to row echelon form. So that means these three numbers need to be 0. So why don't we do that for the first one? So row 2 can equal row 2 plus row 1. And so that's 0, I think 1, -100. Okay, and then so row 2 we're adding, so this will obviously be 0. This stays as -1. This is going to be -1 now because it's going to be plus row 1, which is -1, and then this should become 150, -150. And then we've got 0, 1, 1, 150, right? Second thing could be row 3 equals row 3 plus row 2. And then so this becomes 1, 0, -1, -100. And yes, it becomes infinite solutions, right? So what could it be? So yeah, that would be the interpretation. So infinite solutions. So what would it look like kind of geometrically? Think of like this, because like we can, because there are three variables, think of like planes. These are all plane equations, right? 1, 2, and 3. All of these are plane equations. So think of like one of the planes being parallel to another, and it's like squished together. And then you've got another plane intersecting at a line. So yeah, so that's kind of the solution that you want to think of. We could, so yeah, and that's all it's asking. All right, let's move on to the second question. So for this question, we've already got it and reduced echelon, so that's pretty easy. And then we just need to know our equal to 0. Right? So oh wow. I think I've just like yapped so much. So what part did I like freeze out? Don't let me know. Just anyone? Oh, okay. Well, just this question, right? Question 3. Okay. It's just question 3. I just barely started. So for no solutions, that means that we got 3 zeros in our variables and then a number that's not 0 in our in this fourth column here, right? Which means, okay, let's just say that we already got zeros here, so that means A needs to equal 3 and B needs to equal anything but -2, right? Because if we subbed in -2 in here, that would give us our infinite number of solutions. But we want no solutions, right? Because no solutions means it doesn't make sense. In this case, it means 0 plus 0 plus 0 equals -2. Yeah. So, and then unique solutions, well, we want A, something that doesn't equal -3, and B, we don't want it equal to 0, right? Oh, actually, it could be anything. Yeah, it could be anything. B is equal to a real number. Okay. So, and then infinite, oh, +3, yeah. Whoops, my bad. I'm just blind. And then infinite number of solutions would be A equals 3 and then B equals -2. So this one was fairly easy. to do. All right, let's go to the next one. Lines and planes. So got we're giving a line in parametric form. Oh, sorry, not in parametric, in vector equation. What am I talking about? In vector equation, and then we've got a plane that it intersects. So I need space for this question. Um, so where does it intersect? All right, well, we want to first write the vector in x equals 5 minus, or 5 plus t, y equals 1 minus 2t, that equals t, right? And then you just fuck, how do I do with this phrase? Okay, I might put it on my hotspot and see if it's gonna work. So I'm gonna freeze a bit, but just let me know if my hotspot's better. Uh, okay, I'm back, but is my hotspot better? Like, is it like does it freeze much or no? Was it okay? More pixelated. Okay. Um, okay, let me show my screen. Yeah, my internet is cooked. Um, would you rather this or the internet? But like it freezes a bit periodically. Yeah, okay. Fine, fair enough. Let's do this then. Um, let me share again. Okay, back to this. So, z equals c. Okay, so now we just sub it in, right? We sub our vector, oh, sorry, our Cartesian equation of a line into our plane. So we're just gonna, so we get 4x plus 2y plus z equals 20. Then we just sub it in. So 5 plus t, plus 2, 1 minus 2t, plus t, right, equals 20. And then this becomes, is it freezing? Freezing with this as well? No, okay, let's go back. Okay, I'm back on internet. So I don't know if this is better or if this is worse. Okay, I'm back on internet. So let's go with this. So we get 18, 20 plus 2. Have I missed something? So we should get 22, right? Um, plus t equals 20. Therefore t equals -2. And then we will, so therefore it should intersect. We'll sub -2 back into our vector equation. So r of 2 equals 5, 1, 5, 1, 0 plus 2, 1, -2, 1, and then so we just do math for this, so it should be 7, -1, 2, right? Okay, so B, let's find the plane that passes through the origin at 0, 1, 2 and contains the line and find the Cartesian equation. So we can use the line as the normal. So the direction vector of the line, use that as a normal. So we know that this line equals so let's just say that normal equals 1, 2, 1, -2, 1. And then so we know our plane equation E is equal to R dot N equals A dot N. And we know that A is a point, so we're just going to use A as 0, 1, 2 here. So X, Y, Z dot 1, -2, 1 equals 0, 1, 2 dot 1, -2, 1. And so we get X minus 2Y plus Z equals 0 minus 2 plus should get a 0, right? That's our, does the A not require squiggle? Oh, yeah, but I don't know, vectors, yeah, sure, it's a position vector, so it should require a bit squiggle, but generally, because position vectors are just points. I forget t equals -2. I'm sure oh, yeah, I did. So, um, so what should this be? 3. 4, 5, and then -2. Okay. So back to this. Right, this is P. I'm pretty sure. Unless I'm just so wrong. Okay, anyways, that's fine. I think that should be good. So we get, oh, did I forget the, no, this is fine. Okay, see. So we want to find the intersection between two planes. So we can do the cross product of them. The so you know that P, let's just write the equation down. P equals X minus 2Y plus Z equals 0. The plane Q is 4X plus 2Y plus Z equals 20. And then so when we want to find the intersection, we'll do the cross product between the two normals. All right, so we get N of P times N of Q equals our formula. So this is be 1, -2, 1, 4, -2, 4, 2, 1. Right. Yep. And then so we're gonna expand this because this is just doing a determinant of a 3 by 3. So we get the I in front. We get negative 2, 1, 2, 1 minus j, 1, 4, 4, 1, and then plus k, 1, negative 2, 4, 2. Okay. And then so if we do the terms of these, negative 2 minus 2 would be negative 4i, and then plus 1 minus 4 is negative 3, but it's going to be plus 3j. And then 2 minus 8 is 10. Wait, what? Minus, yeah, it's 10, right? So this should be plus 10k. So you got the direction, and this will be the direction vector of the line, which is what's happening with the intersection. And then so we want to point because we know that the line which it intersects at is in the form of like let's say R of PQ equals a point, right? So call this A on this line plus our plus a parameter and then plus our what we've just done, the NP cross NQ, right? Where T is an element of all reals. So how do we do that? We just let Z equal 0 into our planes. So what we're going to do is let Z equal 0, because we want to find this, right? We want to find what this point is. That includes everything. So when we let Z equal 0, our plane for P is 4x plus, sorry, our plane for P is x minus 2y equals 0. And then our plane for Q is going to be 4x plus 2y equals 20. And then so this becomes y equals x over 2. So you got your equation 1, equation 2. 1 into 2 is 4x plus 2, x on 2 is 10. Therefore x equals 2, right? And then so we resub this into one of them, x equals 2 in 2 in 1, yes. Therefore y equals sub z equals k. Oh, you can do that way as well. So there's multiple ways of doing this. Like it's really not that big of a deal. Yeah. Z equals k also works. So if you do that way is also fine. Y equals 1. And then so you get your point, right? A equals 2, 1. Yeah, 2, 1, 0. And then so intersects at L. R equals 2, 1, 0 plus T, and then we'll get our cross product. Negative 4, 3, 10. And T is an element of L. Okay. So pretty okay, so that's basically it. Aletha, the way that you do it, that's also fine. There's another way that you can also do it, is if you do it, you can also use Gauss on this. So you can do 1, negative 2, 1, 4, 2, 1, 0, 20. Can you also use Gauss for this? It will become like something in the terms of like one, you'll get one here, this will remain. This will obviously become 0 because you cancel out. There's some numbers here. And you want to make it into reduced echelon. And then so because these two are the leading ones, you let Z equals K. And so Elise is right with that one. That one's also a good one. I actually prefer this one, but this way is probably the easier way. I don't know. Anyways, let's move on to question 5. So we want to show that determine the radius such that the line is tangent to the sphere. That means it's only touching one point of the sphere. So we can first, because this is in parametric form, yeah, the point doesn't really matter because it's just a point and there's multiple points on the line, right? So you can do any point and it should be correct, honestly. Anyways, so we've got our line here where it's equal to K, right? So we're gonna make it back into our Cartesian form. So 2K minus 1, y equals 3K, z equals K on 2, right? We sub it in, so we get 2K minus 1 minus 2 squared plus 3K minus 4 squared plus K on 2 plus 1 squared plus R squared. Okay, and then we want to expand all of this. So these are all perfect squares. So let's see, how could I? 4K squared minus 8K plus 4 plus 9K squared minus 24K, I think, plus 16 plus K on 4, so 14K squared plus plus K plus 1, I think, equals R squared. And then what we're gonna do is just add everything together to simplify everything. So we should get 13K squared, 13 and 1/4 K squared, minus 32K plus 1 minus 31K, and then plus 4 plus 16, 20, 21. Someone double check that for me, please. And then we're gonna that's right, that's 3.25 K squared. Minus 31K plus 21 minus R squared equals 0. And so we can use the discriminant here because we know that for one solution, because there's a quadratic. Reduced right echelon form. No, don't even bother. Just why would you, right? You can just back substitute instead of doing more of Gauss, and Gauss you can make mistakes, right? So for one solution, we know that the determinant b squared minus 4ac equals 0, right? So that this actually works out. And then so we can sub in everything, right? So our b squared is going to be our 31K, negative 31K squared minus 4, 13.25K squared. C is 121 minus R squared equals 0. And then I don't have my calculator. So can someone please just do that? Tell me the answer. If someone just needs like give it in like I don't wanna we'll check. No, I don't have my calculator. Someone just tell me the answer for this, please. because I actually have no calculator and I cannot do this in my head at all. So, anyone? Anyone want to give me the answer for R? Um, okay. Anyways, always waiting for that. Let's go on to the next one. So just rearrange for R, right? Oh, sorry. Why is there K's in it? Whoops, sorry. K should not be in there, by the way. It just should be the numbers. I'm an idiot. Negative 31 squared. Yeah, recording will be, I think, whenever Ollie wants to upload it. So, yeah, 1.69, that sounds right, because I remember checking it. Yeah, 1.69. Okay. Okay, cool. Let's go next. So, okay, so we just want to integrate this. So, Cartesian equation of the path. So that means we need to get the position function of this. So, and to do that, we need to integrate it twice, right? So let's just do the integral of velocity. So velocity equals integral of a of t dot dt, right? Which equals 3 sine 3t I plus c1. Oh, sorry, plus c1 I. And then plus negative cos, right? So negative 6 sine 3t j. Plus c2. Whoops. And then so okay, and then we've got initial conditions for velocity. So initially our v of 0 is -6, right? And so well that means that c1 will obviously be 0, right? So therefore c1 equals 0. And then if we sub it in to -6 here, that means c2 will be 0 as well. Okay, cool. And then so therefore our velocity function is just this, right? 3 sine 3t. I minus. Ooh, why am I writing sines? This should be cos. I don't know why I've been writing sines. This should be cos. That's my bad. No, don't put the plus c at the end because this is a vector function, which means that for each component there should be a c value, right? Because yeah, because there's a I component and a j component, which means that we've got to put C1 and C2. Okay. Anyway, so we get this. And then our position function R of t equals whatever R of t equals. So let's integrate this. So we get negative cos 3t C1 I minus, oh yeah, we can do that. It's whatever, honestly, whatever you guys doesn't really matter. Whatever you guys are comfortable with. It's just yeah. C2 again. Oh, let's do C3 C4 so no one gets confused. C4. Right. And then now we know that our initial conditions for this is R of 0 equals 3. Okay, so therefore we know that the x component, r of x equals negative cos 3t plus c3 equals 3. So, all right, got this. Yeah. So what should C3 be? Well, if we sub in 0, sorry, this should be 0. C3 would equal 4, right? Yep. And then Ry equals negative 2 just double checking.
Get around with my cars. Yeah, mostly that.
Okay.
Just like the t-shirts and stuff they have at the.
Equals 5, right? So C4 equals 5. Okay, and then so we've got two equations. I feel like I'm missing something. No, it should be all negatives, right? Yeah, it should be all negatives. I don't think follows negative sign. Negative sign. Cos. This should be positive cos. That's what I thought it was going on. Okay, so of t, so therefore our equation becomes cos 3t plus 4 I minus 2 sine 3t plus 5 j. Okay, and then so we know that x equals cos 3t plus 4, y equals negative 2 sine 3t plus 5. Am I right? To keep double checking. I feel like I'm doing something. Okay, whatever. It's just, it is what it is. So x4. Squared equals cos squared 3t. Y minus 5 divided by negative 2. Yeah. Equals squared equals sine squared 3t. And then we know that cos squared 3t plus sine squared 3t equals 1. And then so therefore our x minus 4 squared plus y minus 5 divided by negative 2 squared. Okay, so that's our Cartesian equation. What is this? It's an ellipse, right? Okay, B. So I wanted to write it in this form. So off the bat, what is our arc? How do we describe arc length? Well, we know that it'll be the integral. What are our domains? It's going to be between 0 and 2 pi, right? And then, well, how do we get the length of when we're going around? If we have our domain, which is between 0 and 2 pi, we just integrate the speed, right? What's our speed? It's going to be the magnitude of velocity, right? And so this becomes 2 pi square root of dx dt squared plus dy dt squared plus dt. Okay. And then so we get Well, what's our dx dt? Well, dx dt is how negative sign 3t squared, negative sign 3t squared plus dy dt is, well, what's the derivative of this? That would be negative 6 cos 3t. Negative 6 cos 3t. And then so dot dt. And then so, well, we get in here 9 sine squared 3t plus 36 cos 3t. Okay. Square root of all of that. And then we can factorize the 9 out. So we can do 9. And then we know that cos squared 3t equals, sine squared 3t equals 1 minus cos squared 3t. Right? So let's get the 9 out first. So this becomes 3t plus 4. Yep. Dot dt. And then so we're going to sub this in. So 9, 1 minus cos squared 3t plus 4 cos squared 3t. Okay. And then so we can factorize the 3 out, honestly. Let's just do that. Well, we know that the inside becomes, well, let's get the 3 out. And then we get 1 plus 3 cos squared 3t. Okay. Dot dt. And then so we know that a equals 0, b equals 2 pi, h equals 1, k equals 3. Right? So pretty easy stuff. And then next question. Okay, let's go to vector calculus now. So, well, this is basically also vector calculus, but this is projectile motion now. Question 7. Yeah, there is a 3 in front. I forgot to add the k in the front when I was writing these questions out. But anyways, that's my bad. So, determine the position functions of both particles. Well, you should just know this by the top of your head, right? So of t equals, well, we know that initially it's projected at t cos theta minus, I plus vt sine theta minus half gt squared. Of bt equals, well, it's starting at the horizontal, so in a initial height, right? But there's initial horizontal velocity, but no initial vertical velocity. So we're just going to do ut. Angle is cos 0, right? So that's just 1. Plus, then h minus half gt squared, right? Because you're starting at some initial position. So there's your two formulas. That's pretty easy for A. B, verify that cos theta equals 1 over root 5. Well, we can just draw the triangle, whatever's easiest. So we got 2, 1 theta root 5. right? Because 10 theta equals 2 and 1, basically. Okay, so how do we verify this? Well, we can use you can draw it like this, and then just say cos theta, or you could have done, we know that the formula for tan theta squared, 10 squared theta plus 1 equals sec squared theta. And then so we know that cos squared theta would have equaled 1 over tan squared theta, because what we've done is just inversed everything. And then this would have been cos theta equals 1 square root tan squared theta plus 1. And then so this becomes 1 over root 2 squared plus 1, which is 1 over root 5, right? So we've just verified that. And then so how do we know that V equals 5 root 5? Well, we just sub it in to our in here. So for our x variable of A, we know that V of t well, we know that, sorry, so we let the x components equal to each other. So xa equals xb. So vt cos theta equals ut. Okay, and then the t's go away. You're left with the cos theta, and we know that's v times 1 over root 5 of u. Therefore, v equals root 5 u. Okay. Okay, C, show that the particles collide at t equals half over 2u. Okay, so this one okay as well. So we at t equals t, we know that there's a collision. So let ya equals yp, so the j component. Because that's the thing that has it. So we'll do p sine theta t minus half jt squared equals h minus half jt squared. These two cancel out. No. We're left with p sine theta t equals h. Okay, so we know that v equals root 5 u. So let's sub that in. So we get root 5 u sine theta t is h. All right, and then we also know that from sine rules, so from this again, this triangle, knows that sine theta would be 2 over root 5. 2 over root 5. So we can sub this in as 5. So let's put this in. So we get root 5u times 2 over root 5 t equals h. Therefore, these two cancel out. What are we trying to equal again? We're trying to make t, right? T the subject, so t, therefore t equals h over 2u. Okay. Pretty easy. Okay, D. Notability. So D is time h if the velocity vectors are perpendicular collision. So that means that if we do the dot product of v dot vb equals 0, and then so that means that VA would be u would be, sorry, VT cos theta let's just do this by hand. Cos theta minus half. And still at t equals t, capital T. I'm just writing out the formula. So let's do this. T squared. Oops, sorry, my bad. This is not the velocity formula. This is the cos theta times u. So times u minus gt sine b sine theta minus gt equals 0. Right? Okay, so for this, we're gonna just expand. We also can just sub in the things that we know already. So like again, v equals root 5 u. And then so we get u squared, root 5 u squared. And then we also know cos theta is 1 on root 5, right? So times 1 on root 5. Minus. You'll get minus gt v sine theta plus g squared t squared equals 0. I need more page for this. So we have like again we know a few things, so let's just cancel out. So this becomes u squared, and then so we know that v again equals root 5, so we can just say, well, this is root 5 u gt sine, sine theta is 2 over root 5, right? So sine theta 2 root 5 plus gt squared, g squared t squared. And then so the root 5s cancel out, and then you get the equation u squared minus 2u gt plus g squared t squared. And then so we can see that this is a perfect square. So it becomes u minus gt squared equals 0. Or you can use quadratic formula, whichever you like, honestly. And then so this becomes u minus gt 0. Therefore, u equals gt. And we know that t equals, where's our first one? H over 2u. So it would be g h over 2u. And so therefore h equals 2u squared over g. Okay. Okay, it's just substituting. All right, let's go next question. Complete numbers. So we got a complex equation. So how are we gonna do this? Let's page actually. So let's question, the first step would be, okay, well, we can just sub in what we know, right? So we know that z conjugate plus b conjugate z plus bz plus c equals 0. And so we can just sub in. So let z equals x plus y, okay? So when we have x plus y, we can just sub it in. So we get a x plus yi, x minus yi, plus alpha plus minus beta, because this is conjugate, I of x plus yi. Plus b, which is just alpha plus beta I, and then x plus yi plus c equals 0. Okay. Mate, you don't need to raise your hand, just ask me the question. Mute your mic and ask the question. Because like, do you wanna, Rohan, do you wanna ask the question? No? You raised your hand. I don't know what you're doing. Yeah, okay, whatever. So we get this massive equation. Now we just got to simplify it, right? So we know that when we get a normal complex number plus its conjugate, we get a perfect, well, it's just a difference of two squares, right? So you get a x squared plus y squared plus alpha x minus beta I x plus alpha x plus beta. Oh yeah, I'm just doing the whole thing, but let's just do it properly. I forgot the solution. So we get alpha x minus beta plus beta I. Oh no, whoops, I'm retarded. I'm actually clinically retarded. Alpha y I minus beta I x plus beta x. Right, that's my first thing, and then we've got to do this second one. Plus alpha x again plus alpha yi plus beta xi minus by plus c equals 0. Okay. So we've got like terms. Yeah, you can actually. Yeah. But what you get is we just add all the like terms together. So you should get ax squared plus ay squared plus 2 alpha x plus 2 beta y plus c equals 0. Okay, we can convert this into a circle because we can just complete the square, right? So let's complete the square. So let's put our x things together. Plus a y squared plus 2 beta y plus c equals 0. Okay, and then so we can make this into x plus alpha divided by a. Oh, like we can get the a out first and then we put it back in. It's just like doesn't matter. Mix and match, yeah, literally. So alpha a squared minus alpha squared a squared plus because I divide by a by everything, I should say that. Yeah. So I should have done that step first, actually. I don't know if I confused everyone, so I've just divided by a through. So this would be 2 alpha x over a plus y squared plus 2 beta y over alpha equals plus c over a equals 0. So you get the mix and matching beta over a squared minus beta squared over a squared plus c over a equals 0. And then so you get our circle alpha over a squared plus y plus beta over a squared equals alpha squared plus beta squared over a equal minus c over a. Okay, and then we know that to represent the circle, we know that alpha squared plus beta squared needs to be above more than AC. Right? So because of this statement here, B conjugate is over AC. So our center is going to be this alpha over A. Oh, negative alpha over A, yes. So negative negative beta over A. And then our radius is square root of that, so radius. But keeping in mind that a squared plus b squared must be bigger than AC. So we can sub it in. You don't have to sub it in. It's not that big of a deal. Like what I mean is this, you could just say, assume alpha squared plus beta squared equals AC. You might get a better, so C minus A. Basically, you just get C minus A. Okay, cool. That's basically this question. All right, this one is easy. I'm not going to go through it. Okay, last question. Are you guys happy that I skipped question 9? Because it should just be like a stock standard thing. Ah, yep. Okay, so Z is east. No, but you got to do all the solutions. So you've got to go through k equals 0, 1, 2, and 3, and then draw it. So you should get like equal solutions, like 45 degrees sort of thing. Sorry, not 40. Yeah. This should be a solution, I think. Right. So yeah. Okay, so conjugate root theorem. So if we know that this is a solution, that means this is also a solution, right? And then so we know that this P of Z is in the form of these two conjugates, these two solutions. So or should I say these two factors? Z plus 2 minus 7i, Z plus 2 plus 7i times by Z minus A. Oh, Z minus C. Let's do Z minus C. All right, that's the form that we have. So we can expand it. All right. So this would be Z squared. What's this number? Our teacher doesn't factorize complex number by inspection. Well, sucks to suck, right? But anyways, this becomes Z squared And then 2 minus 7i multiplied by this equals, what's this? I can't do it in my head, apparently. It should be 4 plus 49, 53, 53, I think. Yep, z minus c. So you get z cubed plus 53z minus cz squared minus 53c. And then so we know that our z squared, negative cz squared equals 6z. So therefore c equals negative 6. All right. And then so b and b equals negative 53c, which is just 53 times 6, 18, 2218. No, my stupid. 318. Right, so therefore, what's A? A is 53. Okay, and so therefore P of Z equals Z cubed plus, how the hell did you get 4 Z squared? What is what I've got is wrong? Can you please tell me where I've gone wrong? It's probably like some stupid thing. Oh, yeah, did it wrong. So let's restart. Whoops. Whoops. Yes. So I did make a mistake here. So yes. So this would be z squared plus 4z plus 4 minus plus 50 plus 49. There we go, much better, right? And then this becomes z cubed plus 4z squared plus 53z minus cz squared. Oh, much better. I thought this was like cz squared uh, minus 4z minus 53c. Oh, sorry, I forgot the c. Minus 53c. Okay. And then so we can group these together. Oh, we don't really care about z cubes. So our z squared component would be 4 minus c, and so that should equal 6. Therefore, c equals 2. Right? C equals 2. And so our z component would be 453 minus 4c, which equals a, which is 53 minus 8, which is 5, I think. Yeah, whatever. And then our sort of our number component, negative 53c, equals b. So B equals, I should write A equals. B equals negative 53 times 2, right? And then so that would be 100 and negative 106. So P of Z equals Z cubed plus 4Z, no, 6Z squared plus A, which is 45. Did I? Yeah. Sorry. I'm just rushing. Negative 2. So this is positive 106. And this is adding. So it should be like 61. Am I right now? Is A 61? That's so big. What the hell? It's huge. I think, yeah, okay, whatever. 61 and then 106 plus 106, right? There you go. And then all solutions. Oh, we've done that actually. So C equals negative 2. So yeah, Z equals negative 2 plus or minus 7i, and then Z equals 2. All right, cool. That's everything. I hope you enjoyed. I hope I was clear because I was like pretty rushing everything. But best of luck with your IA2s. It's all good. I'm sure there was. I hoped there was more people, but no, I'm pretty sure everybody's pretty busy. But something I would like to advertise is Building Minds Tutoring made the worksheet, so check out them. It's pretty cool. But other than that, yeah, I will upload the solutions if you guys didn't follow, and hopefully there wasn't too many internet cuts. So, all right, let me end the recording, and then